Hello everyone, good afternoon, good afternoon. Okay, what about others? Okay, good afternoon everyone, good afternoon. Okay, anyone else is going to join? Good afternoon all. Okay, so friends, now we are going to discuss about the secondary metabolites. As I told you in the morning class to you, all of you friends, we are going to get a compulsory 4 marks question from this particular topic. Good afternoon. If you consider our 2022 February paper, what we understand? We got the part B question also, we got the part C question also. Both questions we got from this particular chapter, from this particular concept. And friends, good afternoon. One of the greatest advantage from this particular topic is there is only 2 ways of asking the question. What is the 2 ways of asking the question? One is in the form of a matching, one is in the form of a statement. Friends, you don't get the question any analytical, any experimental based, any type of question, you don't get it at all. If you get a question, that is a very straightforward question only you are going to expect from this particular topic. Okay, so friends, now let's start. Secondary metabolites. Friends, whatever I am going to highlight right now, you all people try to remember that without fail, because I'll finish the entire concept in 1 hour. Make sure that you follow me very correctly and make sure that you will remember the statements that what I am going to highlight now. Secondary metabolites, everyone remember, secondary metabolites are the compounds which are present in the plant body, correct na? So most of the people will ask, sir, without secondary metabolites, does the plant will work or plant will perform all the essential functions? All the students, keep it in your mind, whether the secondary metabolites are present or absent, it doesn't matter friends. The plant is going to perform all its functions. Everything is exclusively taking place with the help of a secondary metabolites. Don't get confused with that particular point. And all of you listen to me very carefully. Before, all the scientists thought, what all the scientists they thought before they thought that all are the functionless end products. But friends, later they understand, later they come to know that friends, secondary metabolites are having a great functions in the plant body. So secondary metabolites are exclusively responsible for what friends? Defense. Not only defense friends, even they are having a great medicinal applications also. If follow me very correctly, I want you to answer every single question that I will show majorly. So everyone remember, whatever the type of secondary metabolite, it doesn't matter friends, all the secondary metabolites perform a defense function, every secondary metabolite. Okay, so they will help us to fight against the herbivores also. At the same time friends, they will help us to fight against insects also. Don't get confused with that particular point. And friends, they are serving as a attractants for what friends? For the pollinator. I will explain you, don't worry about it. Example, anthocyanin. I have explained this concept very briefly, very elaboratively many times. That's why I am going in a little fast. Okay, so example like anthocyanins, they can act as a attractants. From the longer distance, insects will attract towards this and they will come for the process of pollination. And friends, they are also going to help the plants to deal with abiotic stress like the UV radiation. I will give you the examples also. Let's take an example, flavones. Let's take an example of flavonols. These are all going to protect us from the high intensity of the UV radiation. Good afternoon, everyone. Follow me very correctly. Friends, all the secondary metabolites which are present in the plant body, they are broadly categorized into three types. What are those? Terpenes, phenols, then friends, nitrogen containing compounds. These are all the different type of secondary metabolites present in the every plant. Among all these secondary metabolites, which is the largest class of the secondary metabolites? Terpenes is the largest class of secondary metabolites. Friends, for every secondary metabolite, you have to remember the pathways, you have to remember the precursors involved in the biosynthesis of that secondary metabolites, you have to remember the functions compulsory, you have to remember the types of that particular class. Friends, beyond this, there will be no way of asking the question. Good afternoon, everyone. Please continue. Okay. Trust my words, whatever we are discussing, 90% the question won't go. Okay, maybe the statements will be little confused statement. Otherwise, they may introduce the new terms. But most 90% the question will come from where we discussed. Okay, so in 2022 February we got a different statements, but every time it won't happen. So follow me correctly. Friends, what are the various pathways that are involved in the secondary metabolite metabolism? This is a very important slide which is helping us to understand the overview of all the pathways. So everyone follow me very correctly without having any confusion. See friends, listen. Directly remember the pathways. Mevalanoic acid pathway and MEP pathway. Keep it in your mind. These two pathways are extremely important for the biosynthesis of terpenes. Don't get confused with that. Follow me very correctly, friends. Malonic acid pathway, shikimic acid pathway. Keep it in your mind. These are all extremely important for the biosynthesis of a phenolic compound. So please do not get confused with that particular point. Mevalanoic and MEP for the terpenes, malonic and shikimic acid for the phenols. Let me tell you one simple difference to all of you. Between what? Let me tell you one very simplified difference between the primary metabolites as well as the friends secondary metabolites. What's the difference? All the students listen. Primary metabolites, they are basically formed. What friends? Primary metabolites, they are basically formed from the primary metabolism. Please don't get confused. Now by using the primary metabolites with the help of a different mechanism or different type of a pathways, secondary metabolites can be synthesized. I will give one statement. If the secondary metabolites wants to be formed, there will be a requirement of the precursor. What is that precursor? The precursor only primary metabolites. Don't confuse friends. Primary metabolites only acting as a precursor molecule for the synthesis of the secondary metabolites. I'll go little faster friends, try to cover up. Terpenes. What we discussed, terpenes are the largest class of the secondary metabolites. Friends, keep it in your mind. If we want to synthesize the terpene, what we will be requiring? We will be requiring a precursor. So our precursor or the starting compound. What is the starting compound that is involved in the biosynthesis of a terpene, which is the isoprene unit? Friends, isoprene unit is a how many carbon containing compound? Everyone remember, isoprene is a 5 carbon containing compound. But every student keep it in your mind. If you want to form an active terpene, listen to me friends carefully. If you want to form an active terpene, please remember, minimum we will be requiring 2 isoprene units. Always remember the statement. Without minimum 2 isoprene units, friends, it is very difficult to synthesize this particular terpene molecules. When I want you to remember this compulsory, when 2 isoprene units are associated with each other, we can call monoterpene. 10 carbon, 15 carbon we can call sesquiterpene, 20 carbon we can call diterpene, 25 carbon we can call sesterterpene, 30 carbon we can call triterpene, And friends, what do we call 35 carbon? Don't get confused. 35 carbon we can call sesquarter. Then finally tetraterpene is what, friends? 40 carbon containing compound, and so on. So it is very important, you have to remember the name. I mean, you have to remember the which is 15 carbon, which is 20 carbon, which is 30 carbon. It's very important in the part B also as well as in the part C also. Friends, the terpenes, everyone follow me. Terpenes can be biosynthesized by two major pathways. Just in this concept you no need to do anything except remembering. Remember the concept enough. Two pathways are there, mevaloanoic acid pathway as well as, friends, MEP pathway. Don't get confused with that particular statement. And every student remember, mevaloanoic acid pathway uses what, friends? It is going to use the acetyl CoA. And friends, MEP pathway uses G3P and pyruvate. So by using this as the precursors, they are basically synthesizing the terpenes. I don't want you to remember any kind of a pathways at all, okay? Don't worry. What I want you people to compulsory remember, my friends, the number of carbons and its example. So by using mevaloanoic acid pathway, we have synthesized IPP. IPP is how many carbon? I have explained you last time, 5 carbon. By using MEP pathway, we have synthesized DMAPP. This is also isoprene only. How many carbon? 5 carbon. So friends, now by using these two, we are going to synthesize the terpenes. So when these two isoprene units are combined together, we are going to get the monoterpene. This is what I want every student has to remember for the exam point of view. The example of the monoterpene is the GPP. How many carbons, friends? 10 carbon. Please don't get confused. Now this monoterpene combined with another isoprene unit, it will give rise to the 15 carbon. Please remember, friends, example is FPP because this is also asked in the exam. 15 carbon containing compound we can call sesquiterpene. And if you add another isoprene unit, it will become 20. Example is GGPP, which is the diterpene. Friends, please don't get confused between the GPP and GGPP. GPP is a 10 carbon, GGPP is the 20 carbon. Don't get confused. FPP is what, friends? 15 carbon. Now friends, now as I told to all of you very clear, just to remember the names, don't remember anything. Once again follow me correctly, just remember the name, don't remember anything else. I told you that terpenes are helping the plant to fight against herbivores, and terpenes are helping the plant even to fight against the insects also. Never ever get confused. All the students follow me very correctly, friends. Terpenes, all of you please follow me correctly. Example of the terpenes which are acting against the insect. I don't know what you do, friends, you have to remember the examples. Pyrethroids, monoterpenes, essential oils, I am not explaining very depth, limnoids and phytoecdisone. There are 5 type of terpenes are there which are acting against the insects. What I want you people to remember is example. So the powerful example which is present in the neem tree, which we can call azadirachtin. What is the speciality of this azadirachtin? We have discussed, friends. It is nearly active against 20,000 types of insects. Please do not get confused with that particular point. Next one, phytoecdisones. What are the phytoecdisones? I told to you very clearly last time. See, suppose this is the leaf. This is the leaf. Whenever a herbivore eaten the leaf, now in the herbivore body what are present? Phytoecdisones are present. Now phytoecdisones are entered where? Into the herbivore body. Now what is the speciality? Not herbivore, insect. Phytoecdisones exactly having the same structure of a molting hormone in the insect. First of all, what is molting hormone? Molting hormone nothing but developmental hormones which are involved in the development of that particular insect. Now you know what the phytoecdisones will do once it enter into the insect body? It never stimulate the development. Instead of stimulating the development, they disrupt the molting, which means that, friends, it is disrupting the development which leads to the death of the insect. By that insect never ever touch the plant which is having phytoecdysones. Don't forget the examples. And friends, only remember examples as a revision. There are two type of terpenes are there which are extremely active against the herbivores. What are those, friends? Cardinolides and saponins. Please just remember the names, nothing else. Cardinolides will cause the, suppose example, everyone remember, I am a herbivore. I have eaten a plant which contain the cardinolides. You know what happened? That cardinolides enter in my body, they will show a dramatic effect where on the sodium potassium activated ATPase pumps. Do not get confused with that particular point. Whereas what about the saponins, friends? Follow me very correctly. Saponins are the, listen, saponins are the type of terpenes. They will block the entire functions of the cell membrane. They will block the entire functions of the digestive system. As a result, in the herbivore, the cellular death occur very fastly. Do not get confused with that. Next one. So that is about the first terpene. What you have to remember? Remember pathways in the terpenes. Remember the precursors. Remember the types. Beyond these three, you no need to remember anything. If you get the question, we are going to get the question only from there. And friends, next one, what we are discussing, phenolic compounds. What is the speciality of this particular phenolic compounds? Everyone remember. The moment you heard the name of a phenols, remember that it is the second largest group in the secondary metabolites, not the first one. It is the second largest group in the secondary metabolites after the terpene. It will perform multiple functions. Follow me, friends. You have to remember the statements, nothing else. You know, right? A simplified structure of a phenol, benzene ring with the OH group. So they phenols responsible for plant defense, provide mechanical support. An example, lignin. Lignin is actually a type of a phenol only, friends. And they attract pollinators. We will discuss that example, anthocyanin. Anthocyanin is also type of phenol only. There are some phenol protect the plant from UV damage. Example, flavonoids. That is also type of phenol only. And friends, phenols can reduce the growth of nearby plants. What do we call that mechanism? Allelopathy. I told you last time. Suppose example, there are two plants are living in one particular area, and what is the conditions in that particular area? In that particular area, the condition is that all the resources are limited. So because the resources are limited, friends, both plants cannot survive. There is a possibility of only one plant can survive. You know, that time what happens? One plant starts continuously releasing the phenols into the soil. Through the soil, they will travel and they reaches to the other plant or the adjacent plant. Once they travel to the adjacent plant, you know, these phenols will inhibit the growth of this plant. As a result, only one plant can survive very easily. This process only, friends, we will be calling it as the allelopathy. Do not get confused with that point. Now, you people already remember what are the two pathways involved in the terpenes. Friends, when you compare, you can easily remember. Follow me. Terpenes contains two pathways. One is what, friends? MEP pathway, and another one is what, friends? Mevalanoic acid pathway. Now, friends, what is the biosynthesis of phenols? Shikimic acid pathway, malonic acid pathway. Please remember, don't confuse. Two pathways involved. There is no doubt about it. But the question asked in the part B is, which of the following is the principal pathway? Which of the following is the major pathway involved in the biosynthesis of phenol? Undoubtedly, my friends, shikimic acid pathway. It doesn't mean that phenols cannot be synthesized by the malonic acid pathway. They can be synthesized, friends, but it is a very less significant pathway in the plants. But it is more effective in where, my friends? It is more effective only in the fungus. Never ever forget the statement. So let me explain you. Shikimic acid pathway. See, friends, if I want to synthesize the phenol, all the students listen my statements. If I want to synthesize the phenol, what I will be requiring? I will be requiring a precursor called as phenylalanine. If there is a presence of phenylalanine, we can easily synthesize the phenols. Now the question is, my friends, how can we synthesize the phenylalanine? First of all, see, you know first what happened? Erythrose 4-phosphate and phosphoenol pyruvic acid. You know very well from where this erythrose 4-phosphate has come from. It has come from pentose phosphate pathway. And from where this particular phosphoenol pyruvate has come from? It has come from the glycolysis, we all know very well. Now these two, what they are doing? They are undergoing the shikimic acid pathway, and friends, they are going to give rise to this particular phenylalanine. Is there any necessity to remember this particular pathway? No. See, since it is a revision time, if you are doing from a starting preparation, I will tell you to remember this without fail. But since the revision, don't worry, just remember that phenylalanine is the starting compound required for the biosynthesis of phenols. Now, what are the type of phenols? This you people has to remember compulsory. Phenols are broadly categorized into 3 types: lignins, flavonoids and tannins. All the students listen my statements very carefully. Lignins, see, lignin, flavonoid and tannin. Among the phenols, friends listen to me, among the phenols, the largest class of phenol is the flavonoid. What, friends? Among the phenol, the largest class of the phenol is the flavonoid. This flavonoid further divided into 3 major types. One we can call anthocyanin, another one we can call flavones or flavonols, then the third one we can call isoflavones, or are the isoflavonoid. You people has to remember it compulsory, don't get confused. Okay, now all the students listen. Lignin, whatever the points that I will tell, you people remember the points as it is. You people no need to remember the structures, don't worry. The first point you have to remember about the lignin. Lignin, first point, most abundant organic compound after the cellulose. Correct na? We know that the most abundant organic compound on the planet Earth is the obviously cellulose, because it is the one which will provide the toughness. It is the one which will provide the rigidity to the plant. After the cellulose, lignin is the most abundant one. You all people know, right? Xylem, this is the xylem tracheids and this is the xylem vessel elements. What is the function of tracheids and vessel elements? They are the one which will conduct the water. Now every student imagine, my friends, everyone imagine. Suppose this xylem tracheids and vessel elements are not stronger. They are not mechanically stronger. Friends, what happens if they are not mechanically stronger? If they are not mechanically stronger, everyone listen, there is a chance that they will collapse. There is a chance that they will break. Friends, when they break, what is going to happen? Entire water is getting leaked out. So everyone keep it in your mind that tracheids and vessel elements always should be very stronger. If they want to be stronger, please listen to me, they will be requiring the lignin. So pay attention. Lignin present in the cell walls, notably of xylem tracheids and vessel elements, providing the strength and preventing the collapse of vascular tissue. Never ever forget that. And you know, no friends, follow me very correctly. Sometimes herbivores like a goat, herbivores like a cow, they will try to break the entire stem. Certain cases you might observe, goat, especially goat, they will try to break the stem. The stem seems to be very thin, but it can't break. Why? Because that stem is very physically tough. Who will provide the toughness? Obviously lignin. So that is the first one. And in the phenols, my friends, which is the largest class of the phenol as we studied? Flavonoids. So this is also asked statement in a given 4-marker question. As one of the statement, what they have given? Flavonoids are the 10 carbon containing compound, which is absolutely wrong statement. All the students remember, flavonoids are 15 carbon containing compound, friends. It consists of 2 aromatic rings which are connected via 3 carbon bridge. 6 plus 6 12, which are connected with 3 carbon bridge, total 15. That's why we can call it flavonoids are the 15 carbon containing compound. Don't get confused with that. And friends, what's the major classification of the flavonoids? All of you keep it in your mind, all the flavonoids are broadly categorized into anthocyanins, flavones or flavonol, and friends, isoflavones or isoflavonoids. Very important. I don't know what you do, you have to remember all the statements. I will highlight, you people remember whichever I am highlighting. I am responsible that question won't go. If 4 options are there, 3 options at least comes from whatever we are discussing. That guarantee I can give you. So pay attention. Anthocyanin. Friends, please don't get confused that the anthocyanins are responsible for giving a normal green color. No, they are not responsible for giving a green color. You know, right? The green color is just because of the presence of chlorophyll molecule. We know that the chlorophyll molecules are basically what we can say that they are reflecting the green color. That's why chlorophyll molecule appears to be green. That's why plant appears to be green. When you look into the anthocyanin, anthocyanins are responsible for blue, red and purple colors observed in the plants. Do not get confused with that particular point. All the students listen, anthocyanins are the glycosides. You have to remember this. Anthocyanins are what? Glycoside, where the sugar attached at the position 3. Please look into the structure. This is the anthocyanin. Always at the 3rd position, sugar is present. Listen my statements carefully, friends. If sugar is not present, what friends? If the sugar is not present, we can't call it as the anthocyanin. See here, if the sugar is not present, I mean to say not present, you can look into the diagram. In this example, instead of the sugar, there is a presence of the OH group. Then we can't call it as the anthocyanin. Instead of calling it as the anthocyanin, we will be calling this as, my friends, anthocyanidin. Do not get confused with this particular statement at all. Okay, what is the ultimate function of the anthocyanin? You know, no friends, if the leaf is in a colored blue color, purple color, then what happen? Insects from the longer distance, they will get attracted. What friends? Insects from the longer distance, they will get attract. They will come for the pollination as well as they will come for the seed dispersal. Do not get confused. Now the second class of the flavonoids, that is the flavones and flavonols. All the students follow me very correctly. Don't get confused. See, there is a plant. There is a plant. Inside the plant, what are present? Flavones and flavonols are present. Now we human beings, we can't see the flavones and flavonols. Why? Because friends, the reason why we can't see the flavones and flavonols, the reason is very simple. They will absorb the light of very shorter wavelength. Since they are absorbing the light of very shorter wavelength, they are not at all visible to the human eye. Okay, if they are not visible to the human eye, then who can see that? Obviously, my friends, it can be perceived by the insects. Very important. Okay, now you can ask me, sir, what is the function of a flavones and flavonols inside the plant body? Keep it in your mind. In a given 4-marker question, as one of the statement we can get. What is the statement we can expect? Flavones and flavonols are involved in the formation of a nectar guides. The statement is absolutely true statement. What is nectar guides? Symmetric pattern of stripes, concentric circles or the spots. Everyone look at the diagram. Suppose friends, this is the leaf. Inside the leaf, there are different type of structures are present. Symmetric pattern of stripes like this. Symmetric pattern of stripes, they will be in different colors. Concentric circles like this, or spots like this. So friends, what are the uses of these concentric circles or the stripes? From the longer distance, insect will attract towards that. They will go over there, they will do the process of pollination. Don't get confused. So please remember the statement. Flavones and flavonols involved in the formation of a nectar guides. Not only that, flavones and flavonols which are secreted into the soil, they will be required for nitrogen fixation. Yes or no? Suppose example, this is the root hair. What the root hair is doing? Root hair will release this flavones and flavonols. Where? Into the soil. Once they release into the soil, they will attract the bacteria. Easy mechanism. Once they attract the bacteria will come to the root hair and they will start the nitrogen fixation. Do not get confused with that particular point. Next one, isoflavones or isoflavonoids, the last and final class. Friends, if you look into this structure, I want every one of you remember. You no need to remember the structures, don't worry. Just understand the composition of that particular structure. Anthocyanin having 3 aromatic rings. Flavones and flavonols also having 3 aromatic rings. Friends, isoflavones and isoflavonoids are also having 3 aromatic rings. The only difference is, my friends, isoflavones are isoflavonoids. They are the type of flavonoids only. Don't confuse. They are a type of flavonoids in which one aromatic ring is getting shifted. You can see here, the ring is getting shifted. That's the only difference with respect to the structure, nothing else. These isoflavones and isoflavonoids, example, rotinoids, phytolexin. Rotinoid, this you have to remember, examples is very important. Rotinoid is the type of isoflavone which is having a powerful insecticidal activity. Never get confused with that, friends. The next one, phytolexin. It is an antimicrobial compound. Every student remember, which only released in the plant body whenever the plant is getting affected by the bacterial and fungal infection. Otherwise it never ever get released. There are some other isoflavonoids are there. What is their speciality? They are having anti-estrogenic activity. Do not get confused with this particular statement, friends. It's very important, you have to know this. Now the last and final class of the phenols. Why I am not teaching too depth? Because we studied many number of times. So this is the revision class. You always remember with respect to the revision only. Friends, the moment you heard the name of a tannin, 2 points you have to remember. What is that? One is the condensed tannin, another one is the hydrolyzable tannin. There is no doubt about it. Because friends, follow me very correctly. Actually friends, the tannin can exhibit it in a different forms. Many forms it can exist. But among all the forms, friends, these 2 forms are extremely important forms. One is the condensed, one is the hydrolyzable. I will tell you, condensed tannins are formed by the same monomer. Whereas friends, hydrolyzable tannins can be formed by the different monomer. So what's the point every student has to remember? Since the condensed tannin is formed by the same monomer, you can't break it easily. That's the point. If you want to break it, what do you require? If you want to break it, you always require the strong acid. Without strong acid, you can't break it at all. What about the hydrolyzable tannins? Hydrolyzable tannins are those type of tannins, friends. Every student remember, they are formed from the different monomers. See, they contain the flavonoid, they contain the sugar. No need to remember the structure. Hence, since they are formed from the different monomers, we can easily break even by using the dilute acid also. You take example of a grape, either red color or white color grape. The outer coat or black color grape, outer coat is a type of tannin. The fleshy part what we eat, it is also a tannin. If you take the seed and make it into a powder, it is also a tannin. So that's what tannin can exhibit in a different forms. So friends, we have understand 2 classes of secondary metabolites, terpenes and phenol. Then the third one, most important one, I am not saying that the terpenes and phenols are not important. They are important. Suppose example, if terpenes and phenols are 80% important, nitrogen containing compounds are 100% important, because most of the time the questions will be repeated from all, but more frequently they ask from the nitrogen containing compounds. All the students listen to me. We are using a word nitrogen containing compounds. Why? Because it includes whatever the secondary metabolite that belongs to the nitrogen containing compound. In its structure it contains nitrogen. In its structure it contains nitrogen. That's the reason only we call nitrogen containing compounds. What are the examples of nitrogen containing compounds? Alkaloids, cyanogenic glycosides, glucosinolates, as well as, my friends, non-protein amino acids. Do not get confused with this particular statements. I don't know what you do. You have to remember the four. Okay, I will explain one by one easily and elaboratively. Alkaloids, what you have to remember? They are the large family of nitrogen containing secondary metabolites. You only look into the structure. Everywhere in the ring, nitrogen is present. That's why we can call nitrogen containing compound. My friends, it's not at all necessary to remember the structures. It's not at all. What do you have to remember? Name of the alkaloid class, biosynthetic precursor, example, human uses. Last 2 to 3 times I have explained this particular table very briefly and very elaboratively. Now I am not going to explain too much, but what I want you to do is I want you to remember the entire slide without fail. Pyrrolidine alkaloid, by using ornithine as their precursor, it is giving rise to nicotine. I told you, friends, what is the specialty of a nicotine? When you take the nicotine at low doses, follow me, friends. When you take the nicotine at low doses, it can act as stimulant. When you take it at high doses, it can act as a depressant. At the same time, nicotine can act as a tranquilizer. What is that? Mood changer. Mood changer. Suppose example, when a particular person smokes one cigarette, he or she feel relaxed. So that's what we can call mood changer. Tropane is the alkaloid which by using ornithine as a precursor, it is synthesizing the atropine and cocaine. I already told to all of you, atropine is involved in the prevention of intestinal spasm. Spasm means conduction. All the students listen to me carefully. Friends, our muscles will be like this. They will be easily movable. They will be in the contraction or the relaxation mode. Contraction, relaxation, contraction, relaxation. But sometimes what happen, it will be completely contracted. They won't be relaxed. During that time, to prevent the intestinal spasm, we will use this atropine, and it can act as an antidote to the other poisons. At the same time, it will be involved in the dilation of the pupil. You know, we will just keep one drop of atropine in the eye of the rabbit. Eye of the rabbit, we will keep just one drop. Then we can understand the movement of the pupil. That's why we will use this. And friends, cocaine. I am not explaining too depth because we already studied. Anyway, I am explaining. Cocaine can act as a stimulant of the CNS and local anesthetic. What's the difference between the general anesthetics and local anesthetic? General anesthetics are the drugs which make entire body to lose the sensation. Local anesthetics are the drugs. Every student remember, local anesthetics are the drugs which will make that particular body to lose the sensation. Never get confused, friends. Isoquinoline, biosynthetic precursor is the tyrosine, codeine and morphine. I already told you last time, briefly I explained. Morphine can act as a powerful analgesic and which relieves the labor pain also. But what is the disadvantage? They are habit forming, they are addictive drugs. Now you have to remember, my friends, only at the low doses they are having medicinal uses. You know, when I use the word low dose, sometimes you can also, they will also call it as the therapeutic dose. Anything is same. At low doses or therapeutic dose only, friends, they will be required. They will be acting as the analgesics, which release the pain. And I have also told to all of you, friends, codeine can also act as a, codeine phosphate can act as an antitussive. Antitussives are the drugs which are involved in the treatment of cough. I am requesting all of you, friends, after the class, please look into this table. Please don't miss this particular table. Okay. So the next one, cyanogenic glycoside, the second class of the secondary metabolites. The moment you heard the name of a cyanogenic glycoside, you have to remember that whenever that plant breaks, obviously what it is going to release? It is going to release a toxic volatile gas. What it is releasing, friends? It is releasing toxic volatile gas which we can call hydrogen cyanide. Do not get confused and do not forget. And friends, where the cyanogenic glycosides are present? They are present in the legumes, grasses, rows. But you have to remember friends, in all the plants they are present in the low concentration only. You all people has to remember a very unique statement. Sir, if the cyanogenic glycosides are releasing the hydrogen cyanide, which is a very toxic gas, won't it cause any harm to the plant body? Never ever. It never cause harm to the plant body. Why? Because whenever they are present in the plant, they are always present in the inactive form. They will be remain intact in the plant as the degradative enzymes are spatially separated. What do you mean by that? There is an example of the cyanogenic glycoside named as dhurin. Where the dhurin is present, it is present in the vacuole, and it is present in which form? Non-toxic form. If I want to convert this non-toxic form to the toxic form, I require certain enzymes. But where that enzymes are present? Enzymes are present in the mesophyll cells. So what is the point you people has to remember? Enzymes present somewhere, secondary metabolite like cyanogenic glycoside present somewhere. When they become toxic, when the plant got crushed, when the plant got damaged, when the plant eaten by the herbivore, then only the enzymes will combine with the cyanogenic glycoside. Then only it is converted into the toxic form. Is there any necessity to remember the structure of a cyanogenic glycoside? No, but understand the composition. What friends? Understand the composition. Cyanogenic glycoside contain carbon, sugar and cyanide. Follow me friends. Contain carbon, sugar and cyanide. Follow me very correctly. Listen to me carefully. There is an enzyme called as glycosidase enzyme. What is this particular glycosidase enzyme is doing? This glycosidase enzyme is cleaving the sugar. Follow me friends. Glycosidase enzyme is what it is doing? Cleaving the sugar. Upon cleaving the sugar, cyanogenic glycoside converted into cyanohydrin. What it is getting converted into cyanohydrin. Now this cyanohydrin on its own undergo the decomposition. Very slow decomposition. It undergo the decomposition on their own. Sometimes in the presence of an enzyme called as hydroxynitrile lyase enzyme. It breaks down into ketone and hydrogen cyanide. So what is the point every student has to remember? Hydrogen cyanide can be released in the plant only when the cyanogenic glycosides are break down. If the cyanogenic glycosides are not breaking down, there is no way the hydrogen cyanide never ever released. That's an important point you have to remember. So what are the functions of cyanogenic glycoside? Obviously friends, they are the toxins, right? The cyanogenic glycoside can inhibit all the metalloproteins and several enzymes which are present in the plant. Metalloproteins like nitrogenase enzyme easily inhibited by the cyanogenic glycoside. Cytochrome oxidase, which is present in the electron transport chain, that also can be easily inhibited. If I told you now, we have taken one example. The tribal people in the Northern America, they are continuously eating cassava tubers as their major carbohydrate source. Like however we eat roti and rice, they used to eat this continuously because they are eating continuously this. What happened? Nearly 2 generations got a partial paralysis of limbs because of the cyanide poisoning. Later it comes to the notice of Central Government of America. They created a awareness. Now the cyanide poisoning was drastically decreased. Now the third class, glucosinolate. Everyone remember friends, glucosinolate nothing but we can also call it them as the mustard oil glycoside. Friends, the moment you heard the name of a glucosinolate, first point you people has to remember, this is the only structure, only compound having sulfur in their structure. Nitrogen containing compound did not contain sulfur. Cyanogenic glycoside did not contain sulfur. In the structure, glucosinolates is the only one which contain the sulfur. Never ever confuse. Glucosinolates break down, releasing the volatile defensive substances. Do not get confused with this particular point. They found mainly in the Brassicaceae plant. Example, cabbage, broccoli, radish. When you cut the cabbage, when you cut the broccoli, when you cut the radish, we'll get a good smell, we'll get a good taste. It is because of what? It is just because of the presence of glucosinolate. But we know, right, that smell won't withstand for longer time because they are volatile in nature. They will evaporate very fast. Now, in this particular slide, we have understand how does the cyanogenic glycoside break down. We have to understand how does the glucosinolates are also breaking down. So all the students listen. Glucosinolate contain carbon, nitrogen, sulfur, glucose, oxygen. What? Carbon, nitrogen, oxygen, sulfur, glucose in their structure. Just remember that. Now this glucosinolate treated by an important enzyme we can call thioglucosidase enzyme. What this enzyme is doing? It is cleaving the sugar. Upon cleaving the sugar, glucosinolate converted into a glycone. Every student follow me. Glucosinolate converted into a glycone. Now a glycone once again undergo the spontaneous decomposition, give rise to isothiocyanate and nitrile. No need to remember the structure, just understand what does it contain. It contains carbon, nitrogen, sulfur, oxygen, sugar, glucose. First glucose will be cleaved, glucosinolate converted into a glycone undergo the spontaneous decomposition, giving rise to the isothiocyanate and nitrile. Friends, the last and final class of the nitrogen containing compound I told to all of you, just remember the examples. Non-protein amino acids. What do you mean by the word non-protein amino acid? Name itself indicating don't confuse that they are not involved in the protein synthesis. Actually they are involved in the protein synthesis, but whatever the protein that is getting synthesized, friends, that become completely non-functional. So they can form a non-functional protein. That's the point you have to remember without confusion. Okay, so every student remember examples. Canavanine, agitidine 2-carboxylic acid. Requesting all of you to remember the example. You have to remember the canavanine looks like what kind of amino acid, agitidine 2-carboxylic acid look like what kind of amino acid. That is also important, friends. Canavanine exactly look like arginine. 95% of the structure is similar. See here, just replace this CH2 with oxygen, that's all. Entire structure is same. But agitidine 2-carboxylic acid similar with proline, 1 2 3 4 5 carbon with 1 NH group. Here 1 2 3 4 carbon with 1 H group. So 95% structurally similar. But do you think they are functionally similar? Not at all. They are not at all functionally similar. You know, no friends, arginine is a highly basic amino acid, very highly basic, and this canavanine very low basic. Then whatever the protein that we get, if this is introduced, it become non-functional. So you can ask me, sir, then if they are not forming the protein, then what is their use? Of course, as I said, they are only required for the defense mechanisms only. Do not get confused with that particular points. Okay, friends, don't be hurry, just answer the question which is asked in your 2022 February paper. 4-marker question. Not even single option also, that is not beyond the level whatever we have studied. Sushma, very fast. Okay, phenols we studied, right? Phenols nothing but benzene ring with the OH group, correct na? Which is the phenol. So option A is 4. Alkaloids, definition only nitrogen containing compound. Terpenoids are isoprene unit. Cyanogenic glycoside contain glucose is attached, hence the correct answer will be D. See friends, how easy the question is. Just like that 4 marks are in your pocket. Trust my words, in your upcoming exam also you can get this kind of questions only. So revise it thoroughly. Okay, listen my statements. I have kept 3 extra slides here. Okay, here 3 extra slides. I am requesting right away. Please revise this. 1, 2 and this 3. I want you to revise these 3 slides right away. Just read the information whatever present in that particular slides. Okay friends, that's all for now. We finished the secondary metabolites. So in the tomorrow class we will do the 2 important topics from the unit 7. Okay, and Friday we will discuss about the examination strategy. Okay, because Saturday is the exam, we will discuss the examination strategy. Follow me very strictly in that particular class. Okay friends, that's all for now. I'll see you in the next class. Okay, thank you all, thank you so much. Please revise it very well.